Hello everyone, I'm Erik Kulu and many of you might already be familiar with my work on Nanosatellite database. Let's get started. Nanosats began in 2013 as an Excel file about 8 years ago already, and it has grown considerably both in size and features. I believe by that year there were only about 300 CubeSats launched. The aim of Nanosats is to become the historical record. Most information, all photos, all publications attached, everything I can find. For example, old satellite names and renders are great too because they show the progress and development over time. Updating frequently has not been the goal, but it might become one. One important aspect is that everything should have a linkable source, even if the source is social media or forum post. One advantage is also having planned and cancelled missions. This, together with commercial entities and constellations, enables to notice trends much earlier than it might be possible just by looking at historical data. There are also many concept stage CubeSats that I plan to add in the future to increase that even more. This quote from Dr. Thomas Verbuchen captures perfectly the essence of building nanosatellites. We keep seeing how more and more applications and instruments are being miniaturized that were previously thought to be impossible with CubeSats, while some small volume limitations are being overcome by clever deployable solutions. In some ways, CubeSats are more difficult than large satellites because everything is so tightly integrated and there is very little mass and volume. In some ways, this presentation continues the early CubeSat statistical overviews and trends from SmartBoat, but this time including Constellation spacecraft too. Why am I still working on the Nanosats database after 8 years? I believe the bigger future of nanosatellites is still ahead. We only have 2 interplanetary CubeSats. There are so many interesting missions we could do all across the solar system. And I believe being bound to fit into a box empowers creativity, innovation. Teams must think, how can I do something, instead of taking the easy route and going with a larger satellite. One of the purposes with Nanosats is to increase awareness and also to inspire to aim higher. We have too many similar missions and even satellite names. Teams should really set a goal to have more unique aspects in their missions. Pushing the limits of technology can be more challenging and risky, but I believe it gives larger motivation and it opens up new opportunities that will more than likely make up for it. So what's a nanosatellite in this case? I include all CubeSats, all nanosatellites from 1 to 10 kilograms, and all picosatellites from 100 grams to 1000 grams. Pocket cubes, tubesats and thinsats also have their own categories. I don't include, maybe in the future, femtosatellites, chipsats and suborbital launches, CubeSats that remained attached to upper stages, deep space inspection cameras, older CubeSats before 98, and microsatellites, which are now increasing pretty quickly in numbers. Let's take a look at some challenges and errors. Most nanosatellites have some public information. They are easy to collect. But even in 2021, photos of some CubeSats are impossible to find, and detailed and timely mission status is shared only very rarely. Some do it well though on their personal websites. There are few other sources for structured information with references. For example, a source for an upcoming CubeSat could just be like a screenshot of a presentation, and many CubeSat names are not unique, making search even more challenging. It might surprise you, but proactive sharing of information or offers for help are actually rare, and it's more common with commercial companies. I estimate that the error of the satellite total count is perhaps ±5 spacecraft. There are some unknown objects from military and China, and there is no information about their form factors, so some of them might fit the criteria. With background information done, let's move on to numbers. This is a post I made at the end of 2018. 1000 CubeSats had been launched in the past 15-16 years. And the question was, will the next 1,000 come in 3 years? So where are we at now? Almost 1,700 nanosatellites have been launched, and about 1,550 CubeSats, out of which 1,450 made it to orbit. This graph also shows the running total of one U-sized CubeSat unit, which is close to 4,000. This is the same launch data, but by years. Green is launched, red is launch failures, and blue is announced launch years currently in the database. Notice the decline after record year in 2017 of almost 300 nanosatellites launched. It's very likely that 2021 will have a new record. We have Transporter 2, Transporter 3, and many ISS cargo missions and first launches of small rockets to look forward to. It's unlikely that we'll actually see 700 nanosatellites launched this year. Many of those 700 might be actually cancelled because they have been brought forward from previous years, but I haven't gotten information about official new launch dates. Here we see the current status of launched nanosatellites. Operational is likely lower than the 1,000 depicted on the graph because Constellations and many teams don't announce statuses in later mission phases. Operational also includes semi-operational, which in some ways is a subjective term. But at least the beacon should be sent with some telemetry. I also want to correct the CubeSat failure rate numbers. We have seen 20% or 25% in some presentations, but I don't think that's fair. Once constellations are added, then the failure rate is about 6%. These are the satellites called no signal, nothing has ever been heard. About 100 out of 1,700. And I feel partially failed complex missions can often achieve much more than simplest educational missions, so having a single criteria would be unfair to the teams who have ambitious missions. Here are some of the facts on a single slide. Let's take a deeper look in how many units have been launched, which is about 4,000 one U-sized CubeSat units. Assuming 1.5 kilograms per unit, we get almost 6,000 kilograms for CubeSats, which in a way isn't that much. Many launchers can do it in a single launch. CubeSat constellations have large impact on launch and hardware markets. Planet and Spire are still the largest CubeSat constellations. This year, Swarm is taking third place, and not to take anything away from their achievements, but being a 1/4 of a unit makes it a tiny bit easier. Kepler is now at 4th place with 15 satellites. Astrogast has also launched their first batch of 5 satellites. Most other companies are still only at 1 or 2 demonstration missions, and some very promising like Sky and Space Global haven't come to fruition. Many of them are at least a couple of years behind from their originally announced launch cadences, and it's likely that many of them won't happen at all. This is a map of launched nanosatellites, mostly according to company headquarters locations. As we see, US is far ahead. A lot of it thanks to NASA's ELENA program and educational CubeSats and the largest amount of constellation companies. The most interesting and rewarding is to see the blank spots being filled as years go by. This plot shows the approximate nanosatellites orbits after launched. Some of them have been averaged and grouped. As we see, most nanosatellites are actually in good orbits with lifetimes from 5 to 10 years, and only limited number of CubeSats at larger than 650 km altitude, where orbital lifetime starts to reach 25 years. And it also shows the trend towards lower and lower orbital altitudes. Here is the same launch graph by launchers. The original Delta II, Kepler and Minotaur changed into PSLV and Soyuz, and now we have also Falcon 9, Vega, Electron and many other small launchers. Here's a quick look at the statistics of CubeSat form factors. 3U is by far the most popular, followed by 1 units and then 6 units. Here is the same launch graph by form factors, and 3 units are again clearly leading the pack. Here is the launch graph by organization types. Yellow are universities and blue is companies. As we see, yellow is increasing but relatively stable, so the biggest impact comes from companies. And if the constellations are not happening yet, then that's why the forecasts haven't come true. Launches by deployers. The original B-pod has been overtaken by nanoracks and IC launch deployers, but nowadays many launch providers have their own, which makes the picture very varied. Let's have a quick look at nanosatellite downlink bands. UHF is still the most popular, but now many constellations are using X-band, Ku and Ka bands for faster data downlinks. We also have a handful of CubeSats with laser optical communications. And Global Star, Iridium, is becoming more popular as a 24/7 way to talk to your satellites. I added this graph about company founding dates to show you the peak that happened in 2018. Maybe the subsequent decline is a sign that some hype has passed and we are entering a more mature phase of the nanosatellite ecosystem. And we are close to the end. 2021 will likely set a new record of nanosatellite launches after 2017, but will hit the second 1,000 most likely sometime in 2022. Sizes are both getting larger and smaller. Perhaps some educational missions should move into smaller form factors to save cost, while decreasing launch costs mean that many companies might favor larger satellites to save cost and time on miniaturization. Interplanetary CubeSats are still in the early days, and I feel long-term sustainability of most CubeSat constellation remains to be proven, which makes the market and launch forecasting difficult. Here is the main list of sources that I use. You all know those websites, but all of them deserve much more credit. And this is it. Thank you for listening, and please reach out for any feedback and questions.